Hello everyone and welcome to my YouTube channel. My name is Subhashish Mishra and today's topic of discussion is on visualization using seaborn. If you are new to my channel, please subscribe, like and turn on the notification bell so that you will be notified whenever any new video gets uploaded, as I am constantly uploading videos on machine learning and data science. So this is the first part of the lecture and we will have a part 2 to complete the visualization using seaborn. So now let's get started. So here we are in the Jupyter notebook and let's talk about seaborn. So seaborn is a statistical plotting library which is built on the top of the matplotlib. So seaborn is used for all the statistical plotting, mostly like bar graph, pie chart, heat map, etc. Okay, so in order to install seaborn, we can use pip install seaborn for the all Python distributions, and for the conda distribution we can do the conda install seaborn. We can also be able to use pip install seaborn. So we will install seaborn over here using the notebook, because I've already shown you how you can be able to install seaborn in the notebook. Okay, so let's say pip install seaborn and let's run it. As you can see, for me the seaborn requirement is already satisfied because I have already installed seaborn. But in your case, it will go ahead and install everything else related to seaborn. Okay, so now let's start coding. Now import seaborn as SNS, and then let's import numpy because we are gonna use numpy. So once the seaborn is imported, we can go ahead and access the libraries that seaborn has. Okay, and seaborn also has some data sets that we can be able to use in our statistical analysis also. So let's say there is one data set that we can be able to use. Tips. Okay, so let's say SNS dot load data set, and the data set name is tips. So this tips is the kind of data set in which people go to the restaurant and then provide the tips to the waiters. Okay, so based on that only, this is the kind of data set. Let's say the head of it. Okay, the data set name is tips. I made a mistake. Okay, so here we can be able to see that the column names are total bill, tip, then the gender, which is sex, and the smoker, whether a person is smoker or non-smoker, then whichever day they have gone for, and the time, and the number of people, I mean size, number of people accommodated with them. Okay, so let's go ahead and do the statistical analysis on this. Now let's check the first plotting named dist plot. Dist plotting is basically tells us the distribution of the specific feature. Means it shows a graphical representation of the feature like individual feature. Okay, feature or column and how it is being distributed from start to end. So let's check the dist plot. Okay, so let's go ahead and consider the column called as total bill, and we will check out the dist plot for the total bill. SNS dot dist plot, and then we can go ahead and do the tips of total bill, and there you are. You can be able to see that we have got a dist plot available. In this dist plot, we are getting a histogram and also a KDE plot. This is a kind of plot. This line which is we are being able to see is called as the KDE plot. We'll be discussing about the KDE plot and how it is getting generated later on. But for now, let's just remove the KDE from our plotting, like making KDE is equal to false. Once we do that, we can be able to see that the KDE plot has been removed. All right. So here we can be able to see the number of people in y-axis and the total bill in the x-axis. Okay, So we can say that the maximum total bill lie between 10 to $20. As you can see, the maximum number of people are lying between 10 to $20. So on an average, we can say like people are giving the tips. The total bill is around 10 to $20. All right. Now let's discuss about a plot which works well for the bivariate. Bivariate means more than one variable. Okay, so we can be able to use the joint plot. So SNS plot dot joint plot, and then here we have to provide a x and y and then the data. Okay, we can go ahead and see the documentation. So the documentation says that we need to provide x, y and the data. All right, so these are the important features that we need to provide. So let's say x is equal to total bill that we will be providing, then y is equal to tip, then let's say data is equal to tips. Now once we do that, seaborn draws a pretty beautiful visualization plot for us. Okay, one is total bill, another one is tip. All right, so here we can see the histogram for tip in the y-axis, okay, and the histogram for the total bill in the x-axis, and the scatter plot that we are being able to see, the dots available in between them, is called as the scatter plot. Okay, the scatter plot we are seeing is the connection between total bill and tips. So wherever the tips and the total bill are just joining and forming any kind of equation between them, wherever itself there is a scatter plot present. All right, so we may be able to see that say that it is the scatter plot is a relationship between tip and total bill. All right, so we can be able to change the scatter plot also. We can be able to change it and provide that any kind of other plotting that we want. For that, what we need to do is like kind is equal to say hex. So it will have hex plot for us. Now this kind variable that we are providing over here is a kind of very powerful tool. We can be able to provide any kind of plotting that we want. We can be able to provide it like histogram, it's a hexagonal, it can be any kind of like box plot, any kind of other plots like scatter plot. Okay, if you are not providing any kind over here, then the default plotting is scatter plot, by the way. All right, now let's discuss about pair plot. So pair plot is used to provide us pairwise relationship between numerical columns. What is pair plot and pairwise relationship? We will be discussing over here right now. So pair plot will show the all possible pairwise comparison between all the columns we have in the data frame. So pairwise is used to identify how similar is one group of data with another. So pairwise is basically used to identify one group of people. Let's say we have one group of people available with us and we want to compare them and know the similarity between those pair of people or those group of people with another random group of people. Okay, so this is called as pairwise comparison. So let's see the pair plot then. SNS dot pair plot. Inside pair plot, we can be able to provide the data frame itself. So once we do that, it provides us the pairing with each and every column with other columns. Okay, like here we can be able to see that size step total bill is being compared with size step total bill. Now notice one thing is like if we go ahead and see the data frame, then we have total bill, tip and size got considered, and the sex, smoke, date, time, though these are got discarded. Why? Because the pair plot usually considers numeric data into the consideration. Okay, not the categorical data. If we want to add a categorical data into that, then we can be able to specify it using another one argument called as hue. Hue is the argument which is being used to add any kind of categorical column into categorical flavor or categorical column into any kind of visualization that we are doing. Okay, for that, let's say we are taking the sex as the categorical column. Okay, so once we do that, we can be able to see that the legend for male and female is being drawn. The male is blue, the female is orange, and we can be able to see that the scatter plot, uh, all the plotting that we are being able to see, the KDE plot also, those are showing us everything else related to the male and female, like blue and orange is being completely distinguished in between blue and orange. Alright, now let's discuss about rug plot. Okay, so rug plot is also used in univariate series. Let's go ahead and do it. SNS dot rug plot. Sorry. And let's say we want a rug plot for same total bill. So once we do that, we can be able to see that there are very tiny lines drawn over here. Okay, so what it does is like it draws tiny bit of lines wherever we are considering any kind of data points presence. Okay, so it tries to draw each and every data point by using one line. So here each and every single line is a that represents one data set, one data unit. Okay, so this is how the rug plot is being built. Rug plot is very much used in case of KDE plot. So whenever we will be discussing about KDE plot, we can be able to understand the relationship of rug plot with the KDE plot. Okay, so without any further ado, let's discuss about the KDE plot also. So KDE stands for kernel density estimation plot. So based on the rug plots, we draw the normal distribution of the data points. Okay, based on the rug plots, we basically draw the normal distribution of the data points. So wherever the data points are high, we provide the normal distribution over there. Wherever the data point is low, so it's basically the spread of the data we are creating with using the rug plots. Once we do that, we can be able to combine them to get the KDE plot. Alright. Now, what I mean by that is, let's say we have SNS dot best plot that we have already drawn over here. It's like tips. This one we have done earlier in this lecture. Okay, so we have done also KD equal to false. Okay, now we can be able to see that for this hist there will be a normal distribution like this way. For this hist there will be a normal distribution like this way. So there will be lot of normal distributions, and joining all of those normal distributions, the KDE plot get created. Now let's create a KDE plot. Okay, so I'll be typing a lot of codes over here. Don't worry, you don't need to understand it because it's just a representation of the normal distribution and how we can be able to derive the KDE plot from them. Now let's go ahead and understand the code of it. Here I'm importing NumPy and then the matplotlib, then the SciPy. Okay, and here is the data set that I have created using NumPy, random data set of 25 numbers. Then I have created the rug plot of the data set. Then I said set x-axis and y-axis, okay, based on the mean and max, and then 100 equally spaced point between x min and x max. Okay, I've created another one data set which is spaced between x min and x max. Now once that is being done, we are plotting the normal distribution for that. So let's run it, and we can be able to see that there are a lot of normal distribution plots available. Now if you go ahead and see carefully, there are certain small lines present over here. So these small lines are nothing but rug plots, and based on the rug plots the normal distribution lines are being drawn. Now let's go ahead and join all the normal distributed lines to get the KD plot. So once we join all the normally distributed lines, we can be able to see the KD plots over here. So here also we can be able to see the raw plots which we have seen the normal distribution plot also. Alright, so this is how the KD plot gets calculated and it's derived from the normal distribution curve. Now let's discuss about the bar plot. So for bar plot, you can go ahead and do start bar plot. The sex is the categorical column we want, and tip is the numerical column we want, and data is the tips. So it will show the average value for the group based on the gender as male and female. So it basically is a kind of group by operation. Okay, so group by operation, if we want to plot it in any graph, then we can be able to use the bar plot. Here we are giving the sex as the x-axis and y as the tip as the y-axis. So it will segregate all the tips and will give us a mean value or the average value of each and every gender based on male and female. So as you can see, this is the average value of male, this is the average value of female. Okay, the tip provided into the weights by the male and the female is being averaged out and is being showing over here using the bar plot. By default, the estimator in case of the bar plot is mean. That is the data calculated based on the mean to plot the graph. We can go ahead and change it if we want to. Okay, so for that, what we can be able to do, we have to add another one argument. Estimator is equal to, let's say we want max value. So np.max, if we do np.max, we can be able to see the maximum value for tip given by the male is 10, the maximum tip given by the female is around 7. Okay, we can be able to find the count of categorical series or columns by using count plot. Okay, so if I want to know that how many male are there, how many female are there, I can be able to do that using the count plot. So go ahead and do the count plot, and in the count plot, the categorical value that we will be providing is sex. Let's count all the male and females, and the data is so once we do that, we can be able to see that there are close to 160 male and there are close to 90 female who are being considered in this data set. Alright, now let's discuss about one more very important plot called as box plot. It is used to show the distribution of categorical data. Okay, so now let's draw one of them. SNS dot box plot. This will be very much used in case of any kind of outlier distribution. Whenever we'll be going ahead and discussing about any machine learning model, then when we want to find out the outliers or the anomaly, then in that case we can be able to use the box plot for the anomaly or outlier detection. Okay, so let's go ahead and say x is equal to day. This is the category that we want, and we want the distribution for the tip column for each and every day. Now the data is tips. So once we do that, we can be able to see that the box plot is created. So this box plot shows the quartile of the data and the whisker shows the extension of the data. So this is the quartile of the data. This box is quartile of the data. This whisker shows the extension of the data. We can also add one more extra categorical data in the box plot. Okay, so how we can be able to do that is using the hue. Let's say we want to know who are among them are smoker and who are non-smokers. We can be able to do that. So if we add smoker and non-smoker, then it can be able to categorize people based on the smoker and non-smokers. So the smokers are blue and the non-smoker are yellow. Alright. Now let's discuss about violin plot. Okay, this is very rarely used, but it has a very much good and very much wide representation. It is little confusing in case of understanding, but it has a lot of aspects of understanding the data. SNS dot violin plot, and then we will use the same that we were doing before, like x is day, y is step, and data is steps. So once we do that, we can be able to see that based on the each and every day the violin plot got printed. Okay, so tip value for each and every day's violin plot is plotted over here. Now okay, so if we want to know that if we want to, there is a option called as something that we want to add. Okay, if we want to add anything else, then we can be able to add any kind of other categorical data also. Let's go ahead and consider this as sex for now. I'll explain you why we have done that. And using u, we can be able to add another one categorical variable. Then let's take day as the categorical variable. And based on that, we can be able to see that for each and every day, we have got two different violins available for us. Okay, and which is based on the male and female. Now, if we want to split each and every data, like this is the violin plot that we have. This is male, male, female, female available for each and every day. Okay, so if I want to print like one side is blue as male, another one side is let's say orange as female. So how we can be able to do that? We can be able to use a split. Okay, an argument called as split. So if we do split equal to true, then it will give us the split value. As you can see, first half is blue, which is male. Second half is kind of orange, which is called as female. We can also have a strip plot, which is basically similar to the box plot and violin plot. Like we will have one categorical data and one numerical column, and we will be able to see the comparison also. So we can draw it using SNS dot strip plot. X is equal to day, y is equal to tip, theta is equal to x. So once we do that, we can be able to see the strip plot also. Alright. We can also add the split over here also. Like we can also add the hue. So hue is equal to sex. You can be able to see that male is blue and female is kind of orange. Now we can also be able to split, distinguish between male and female. So it will split male separately and female separately. Okay. We can also combine the violin plot and strip plot together and get a new plot named swarm plot, which will showcase all the points. Okay. So let's go ahead and see the swarm plot. SNS dot swarm plot will be same that we were doing before. X is day, y is step, data is steps, Once we do that, as you can see, we have a swarm plot available. So it is quite widely distributed and we can be able to segregate each and every data points easily, which wasn't the case in case of the strip plot. Alright, the major disadvantage of a swarm plot is that for very large number of data set, it will not be able to justify the distribution properly. Okay, if we have the data set is very large, then the distribution will overlap it and it won't be able to properly provide us the result for this. Okay, now let's discuss about very much important plot, which is called as factor plot. Factor plot is equal to day, y is equal to f, data is equal to tips. Okay, now here one important aspect that we have is kind, where we can be able to specify which kind of graph we want in factor plot. So if we are specifying bar graph, then it will showcase us bar graph, as you can see. If we specify scatter, then it will plot a scatter plot for us. Showing error. Okay, maybe the S is capital. Let's see. Oh. Check out the box plot. Yeah, the box plot is being plotted. I don't know what's the problem with the scatter plot. We will go ahead and see it. I will encourage you go ahead and give it a try. Why is it giving an error for the scatter plot? You go ahead and give it a try on your own. And this is the first lecture of seaborn. We will have another lecture for seaborn, which will be the closing of the visualization. Then we will go ahead and discuss about the machine learning models one by one and all the steps to go ahead and build a machine learning model. Until then, stay tuned and enjoy machine learning. Thank you.